muted. Let's try that again. I was slightly muted. Hello and welcome to the Teardown sessions. My name is Helen Leigh, and we are here today to talk to the folks behind the Modos system. I'm going to bring them on in a minute. Before we do that, I am going to show you what's going on at Crowd Supply. Here's the Modos Paper Monitor that you're all here to see. I've seen this in person. It's very exciting, particularly the latency, but I'm not going to tell you too much about that. We're going to bring those on in a second. Let's see what we've got going on with us. We have got DeckSight. This just launched this morning, I think, a drop-in low-power OLED display upgrade for your Steam Deck. Lots of people are excited about that. As I say, just launched and already 15% funded. We have Hornet's Nest alarm panel that also just launched, a Home Assistant compatible wired home automation system. So if you like home automation, but you also like wires, yeah, check this out. We've got also an eval board for the Onion Omega. Those are the three things we got recently. We also have the ESP32 Rainbow. This is surprisingly large. It's a ZX Spectrum single board computer with beautiful PCB work. That's pretty fun. That's got 7 days left. So if that sounds like exciting, like an exciting product to you, you've got 7 days left to support it. We also have 3 hours left in this campaign, the X1 Plus Expander. If you have a Bamboo Lab X1, this is for you. If you don't, it's not. I have a Bamboo Lab, they're fantastic, and the X1 is the top of their line. So I know lots of people with the Bamboo X1 are very excited about this. Also, with 3 hours left, we have a USB interfacing tool, which is it's gone pretty well. They've passed their goal. They've got 3 hours left if you want to get in on that. 2 more left. Gosh, we've got loads of projects live this week. Signaloid microSD is a programmable FPGA, field programmable gate array, SOM, system on module in the tiny microSD form factor. I do love a tiny piece of electronics, and Signaloid's a great person, so do support that. You've got 7 days left. And then the final campaign we've got going this week, where we really did have a lot of these this week, is the Solder Ninja Pen from the delightful Nicholas. I actually have one of these myself. It's been a pleasure to watch him develop this, and I know he'll be happy that he's raised almost double his goal. 3 hours left to support that. So if you want a fancy milled aluminium, depending where you're from, soldering iron that takes Weller tips, this one's for you. I'm a Weller girl myself, so I'm happy to have a USB-C soldering iron that finally can use proper tips. So there we are. Whew, that's a lot of projects to get through. I also wanted to give a shout out for Teardown 2025. This is our annual conference of hacking and hardware, practical electronics. This year, our keynotes are Cory Doctorow, Kate Stewart, and Bunny Huang, 3 top quality speakers. And it's a really fun event that we hold in a semi-abandoned mall. And this is the schedule from last year. You can see here, Wenting Zhang, Making E-Ink Go Fast. This was one of our more popular talks from 2024. And we're going to be hearing about this here. So this is the design of the Caster project. And this talk was there. You can actually still see this talk online. So do check that out. Now, without further ado, I'm actually going to bring these folks on that you're here to hear from. So this is the Modos Paper Monitor, and here are the folks who have brought it. Let me remove the screen so you can actually see their lovely faces. Hello, Wenting and Alex. Lovely. Thank you for joining us here. Thank you very much. Hi.
Hi.
Can you please explain to these people who you are and what your project is?
Sure. Well, my name is Alex. Yeah, I'm sort of a founder or co-founder really of Modos, and here we're working on the Modos Paper Monitor.
Yeah, hi, I'm Wenting. I'm also co-founder of the Modos, and of course we're working on this Modos Paper Monitor. And I'm mostly on the hardware engineering side, and he's on
everything else.
Yeah.
All right, but before we dive in, I just wanted to take a moment to see who's joining us. We've got Isabella, who is joining us from Germany. Hello, Isabella. Thank you for joining us. Someone called Influencer LOL, which sounds like they're very much their real name, from Canada. We've got someone saying hello, everyone. We've got someone here who's joining us from India. someone else from Germany, and someone locally from Portland, Oregon. Nice to see you all. There's some more questions and comments here in this chat, but I'll bring them up in a bit. So could you please tell us a little bit about why people are so excited about the Modos Paper Monitor? Because they are. Honestly, including me, I've been watching this develop for years, and I'm very excited about it. And when I first saw the fully working prototype at, I think it was the Open Hardware Summit in New York, maybe, or maybe Montreal. I can't remember. Anyway, yeah, it was Montreal. And the first time I saw it actually working, I gasped. It was very exciting. I've never seen e-ink with this kind of like latency. So, like everybody else here, I'm very excited to hear about how you did it.
Okay. Well, that's a lot.
I know it's a lot.
Yeah, I think I'll go with maybe first talking about the reasons that people have been excited.
We should first talk about like what that is.
Yeah.
You want to go?
Yeah. So as you can see, it's an e-ink monitor. E-ink is the screen technology that usually used on e-readers like your Kindle, or sometimes other stuff like shelf labels in supermarket, grocery store. It's bistable. It looks really like a paper, but the downside it's really slow. And then there are existing products on the market trying to make it into a monitor, and got some varying degree of success. Of course, all of these products work as a monitor, so it means you can do your usual stuff or browsing or typing, writing letters or coding on an actual ink screen, which feels like a paper and probably help in other ways. But it's just too slow because e-ink is a slow technology. The screen itself is slow. And then it doesn't really work too well if it's an interactive thing, say you're typing. It works okay for Amazon guys. They're just doing Kindle, so you're just reading. It doesn't matter if the screen is a little bit slow. But it's really killing the experience if it's a monitor. So our work is really trying to see if we can make it work. Given the screen itself is slow, but can you make the experience actually better? That's pretty much the whole project is about, like making an actual usable ink monitor.
Yeah.
Yeah, and then talking about the reasons people are excited, I think part of it is, a lot of people are spending about 7 to 8 hours a day. They experience some form of like eye strain. They prefer the sort of black and white, sort of like minimal look. So a lot of like knowledge workers, for example, are people who've sort of expressed interest. Like a lot of people are software engineers, students, just anyone really who has to spend a lot of time in front of a computer. That has been like kind of like one major group who's expressed interest. I think the other major group really is like makers, right? Makers, people who sort of see this, who I think there's a sort of aesthetic, beautiful quality that's kind of hard to like pin down when you look at an e-ink screen. I think by having an open display controller, that really kind of opens up the room for like makers to be able to make their own projects, build on top of it, and also be able to improve it as well. And I think there's also sort of like another community as well. Well, I think part of it is by being open also kind of lends itself a bit more to repairability as well. So that's something as well that we're seeing. And then, I think a few conversations I've had. I remember when I was at Teardown, there was someone who was a professor at NYU, I want to say. I could get that wrong, but they were part of this sort of processing community, or P5.js, which does a lot of like art. So they were interested in using e-ink screen for that. But we received a lot of comments, or we received comments like that using for like art, for personal reasons due to eye strain. People want to build on top of it and do something else. Other people just find it really cool and just want to be able to use it.
And can I ask a question about, so one of the things that I know people use e-ink for is because it's, quite low power, right, compared to a typical screen. But when you're increasing the latency like this, how do the power demands change? Are you seeing, yeah.
Yeah, so the power consumption, the e-ink itself is still pretty low power. The thing that's consuming the power is the FPGA inside. So I had to use an FPGA as a controller for this monitor. And FPGA isn't the most power-saving thing, so it's using the majority of the power. And the FPGA, just by running it, it's using like 1 watt continuously. So that's pretty much the overall power consumption.
Which FPGA did you choose?
We're using the Spartan 6.
Okay. And why did you choose that?
Yes, that's also like a frequently asked question, like why do you use such an old FPGA? The thing is, the newer is not always better, right? And the Spartan 6 actually have two major features that's missing from their newer generation FPGAs. One is the hardened memory controller. So on 7
Can you
series
explain
FPGA,
what that is?
yes. So on FPGA, so at least for our application, we do want an external DDR memory, large buffer memory to store the image and do something with that. And then on Spartan 6, they have hardware support for that interface. So they have this hardware controller built into their FPGA outside of your programmable logic, and you can just use. And on newer devices like Arctic 7 or Kintex 7, they remove that. And instead, you have to build a memory controller using the logic. They provide a soft IP as a bundle of their software. So you can just instantiate their already built IP in your newer FPGA and have it work. But the downside is, other than just using more your programmable logic just for a fixed function thing, like a memory controller, it also consumes way more power. So that's quite unfavorable for us because we do want it to be low power enough. And with really the entire system power consumption depends on how much logic you use. But we find with our design, Spartan 6 actually use less power. This is one feature they removed from the 7 series. They added back in the Ultra Scale Plus, but then Ultra Scale Plus is a little bit too expensive. And then another feature they removed in 7 series is suspension. It allows the FPGA to suspend without losing its state. They removed suspend feature in the 7 series.
Oh, well, I can see why you'd need that.
Yeah.
Okay, cool, interesting. Well, I've got to take a couple of minutes here. We've got loads of questions and comments that I'd like to just quickly shout out. So someone says, I was at Teardown this year in Portland for this talk. It's fantastic. Thank you for sharing, and thanks for posting it again. I hope we get more updates from the Modos, folks.
Thank you very much.
And then we got Rainer saying, what is there to tear down? It's just a panel and controller board. Well, firstly, Teardown is kind of what we call our conference and our live stream series, but also what you tear down based on components, not just, you can do a teardown based on like what components are on the board. So we could have torn this down, but it's not. It's just the name of the show. But they also said, what I'm interested to know is how long the display lasts for continuous use at 30 or 60 frames per second. Is that you want to give a quick answer to that, or is there no quick answer?
There is no quick answer because it actually not just
a long one
on the frame rate. It also display on what you display on the screen. So there are certain things that certain patterns that's more power hungry than others. So it's really about how much power is going through these connections. And it's usually not the pixel it goes bad. It's the connection between the board and it's the connection between the screen and the controller chip. That the bonding layer goes bad sooner than everything else. So it's really just related to how much current is going through that and how much power is going through that. That's really the thing that's affecting it. So if we say if you're just typing or is playing some not very hard thing like playing a bad app or something like that, you just continue playing that at 60 FPS, it should continuously last for half a year without issue.
Interesting. Okay. Okay, we've also got someone saying, we're waiting, Modos, and thank you, Mr. Zhang, for your hard work, and the rest of the team, of course. We've got a question here saying, what about the phone form factor device? Is that something we should talk a little bit about form factor here, actually, because the first time I heard about this device, it was actually a laptop, and now it's a board. So can you talk us a little bit through your plans for this device and like the form factor decisions that you've made?
Yes, trying to see how to approach that. So I think stepping back a little bit.
Let me just remove it so you can see the actual. form factor itself there.
Yes.
Yeah.
So we initially were starting with a laptop. I think that was a primary like the motivating like force to be able to
Yeah.
work towards that. Way too hard. I think way too hard. We started working on the controller, doing tests, and then we were having support from someone who was interested in kind of supporting. We were kind of like value aligned, but we decided to start an open hardware company amidst a chip shortage and during the COVID pandemic.
Chip shortage.
If anyone like has
It was
experienced
quite difficult to get an FPGA back then, if I remember correctly. I remember people begging for
We have
FPGAs on
stories.
Twitter. Oh,
Yeah.
we've all got stories. We've all got stories.
So we decided to go for like what is feasible, what can we do right now.
Yes.
So this is where we are today with the monitor that you see right here. So this is kind of the form factor. We also have the board here that I can show a
Let
little
me
bit later.
spotlight you so you can actually see this.
So yes,
Yeah,
so
here
this
we
is our
go.
board.
Beautiful.
I think once we can do a bit more of a breakdown, maybe in a little bit. But yeah, so this is what we have here. I could show different modes, but ideally not in this version, but there'll be a kickstand that'll be with the monitor itself here in the back. But I think we can showcase a little bit, maybe more of the monitor. But
Yep, totally.
this is the current form factor. I don't know if one thing you want to add to that.
Yeah. So as he said, like doing a laptop is really just really hard. We need not just solving the screen itself. We need other issues at the hinges. We have issues at keyboards. We have issues at the touchpad, and touchpad actually doesn't work. So we actually want a track point, something like that, instead of touchpad, and that just make the whole thing much more complicated.
Yeah.
That's why we decided to scale back a little bit. We just do the monitor, start with the monitor, and see what we're going to do in the future. Because
I think it's a good idea.
Yeah, the comment is specifically asking on the phone. I don't think phone is going to happen anytime soon, just because our overall architecture of using the FPGA, that's kind of power hungry, so that doesn't go into phone very well. But that's something can be optimized. So I wouldn't say like we will never do a phone, but also saying like the very next product probably is not going to be a phone.
Yep. All right, we've got someone saying hello from France, and they've also asked, when will the campaign start? Is this a good time? Let's talk a little bit about your plans for the immediate future. What's going on? I know we've had a pre-launch up. I know there's been a lot of excitement about it. I know lots of development has been done. Are we near the finish line? What's the deal?
So, we have an open hardware company that started amidst the chip shortage and pandemic. And, you still have Mother Nature, tsunamis happening around Japan and China that caused some delays. So we had a bit of a delay in receiving some panels, and we're focusing right now on the ejection molding for our chassis. So that kind of set us back a little bit when it comes to timing. So that's something to look into while communicating here. But we are also kind of like working towards that. I think Wenting, if you could maybe elaborate a bit more on the scheduling.
So just to say the tsunami situation, like we ordered some panel from E-Ink, which they're located in Taiwan. So the route is they're going to ship it from Taiwan to Hong Kong, then Hong Kong to Ningbo, where our contracted manufacturer is. And then as soon as they hit Hong Kong, like the area was hit by tsunami, so the ship has to stay there for like 2 weeks, and then it departed from Hong Kong harbor and arrived in Ningbo. Then it hit by another tsunami, so I had to stop in Ningbo for another 3 weeks. That's kind of crazy, but now the panels have arrived, and we're working with their engineers to really change the design, because the current chassis design is really just for 3D printing to see how it looks like.
Yeah, for sure.
Loading, they need to do tons of other tweaks. Working on. And then also, like me personally, if you watch my talk, you know I'm a full-time engineer, chip engineer, working here in Cambridge, Massachusetts on chip design, completely unrelated. But chip design is not entirely an easy work. That means I have to find my free time to actually work on this project other than just improving things, writing code, also talking to their engineers, all these kind of stuff. So I really don't have much time. And that's just seeing things are overall going really slow, but then this product is really getting traction. I really want to see it happen. So I'm in a position, I've resigned from my current job. I will work on this full time. And I will move to Shenzhen to work on this.
That's amazing. So you have quit a job and you're moving to Shenzhen to concentrate on getting this product over the line.
Yes.
That's very exciting. You're gonna have a good time. Have you spent much time in Shenzhen before?
Not much. I probably spent only several days there, but hopefully it will go smooth.
It's a fun city. Well, I mean, I don't know. Like I spent a lot of time there, several, but it was before the pandemic, and I hear it's changed a lot since then. So probably my knowledge is all out of date at this point. But I'm sure you'll have a great time, and I'm excited to see. Do you know where you're going to be working at? Are you going to go to one of the hackerspaces, or do you have any? Or are you going to get an office, or do you know what your plans are for Shenzhen?
Yeah, I'm gonna get. Well, first I'm renting an apartment.
Okay.
I need to have a place to live.
Yeah, that might help.
Yeah, and then I think starting from there, we'll see.
Okay. But you still didn't answer the question. When's the campaign starting?
Yes. So the hope is we'll have everything ready before the Chinese New Year, which would occur by the end of January. And once we have that ready, we can hopefully start campaign in February.
Yep. Okay, great. Oh, that's exciting. Okay, so a February campaign. All right. Okay, good. Okay, fun times. We heard it here, folks. February campaign. All right, let me see what else I've got on any question. Here we are. So question for Wenting. Have you looked into other FPGA vendors like Lattice, for example, the ECP5?
Yes, that's a good question, because the very, very, very first version of the board was using ECP5.
I didn't know that.
It would make a lot of sense, and it was during chip shortage, and ECP5 just was available, so I used ECP5. And then I found out the Diamond, which is Lattice tool, the DDR controller for it actually required me to purchase a separate license rather than just bundle. So I need to buy another license just to use a DDR controller. At that time, I just want to. That was many years ago. Like I just wanted to do a proof of concept to see if the fast refresh idea I have actually work or not. So I wasn't quite ready to spend money on the license or dive into porting one of the open source DDR controller to the ECP5, let alone like I have no prior knowledge or experience with ECP5. So I thought, okay, then I'm not going to do with ECP5. I can just do Spartan 6. That platform I already know, so it's easier for me to program. Program is just like back then was a little bit harder to source. But
yeah. Okay, cool. Good answer. I've got another question here saying, is the hardware final parts for production? So how confident are you in your board design at this moment? Do you expect any major amendments or?
Yes, the current this board is actually not the latest version. I've already made a few more changes. One is the new board is actually larger, so I have places to put down more EMI shells. That's one thing. The other thing is I said like one major thing that's affecting the lifespan of the screen is not actually the FPS, but the power going to the panel, and that depends very much on the image being displayed. So on the new board, it has way more voltage and current monitors monitoring the power consumption of the screen, and then throttle down your frame rate to avoid, prematurely break the screen.
Yeah, cool. Okay, so we also have another. I'm going to come back to you, and we can talk in a bit more depth about how you achieve the latency you achieve. But I just wanted to get through a couple more comments first. Someone's asked, do we know what kind of price point this monitor is going to be sold at? Have you fully costed it out yet, or do you not know? Do you have an idea?
I think we're still working on that with the injection molding.
Yeah.
When I first purchased my monitor that was e-ink, it was $1,200.
Oh! Yeah.
When I first purchased mine. Not $1,200, so we're going to say that much. But I think it will be priced competitively with the existing options as well. I think that's like the close that we can say right now.
Yeah,
All right.
and the competitors, they are lowering their price, which means we will gonna to have lowering our price as well.
Yeah, very cool. Okay, so I'm going to go back to you now, and let's talk a little bit about, in more depth, if you'd like, about the how to make e-ink go fast. So, can you talk a little bit how you've approached that and how you've achieved that, and kind of what standards you're managing to reach?
Yeah, so I think one thing to be clear is we are not using any. Well, there are generally many ways you can do to make it fast. One is of course using a faster panel if that's available, and turns out that just made available before we do our pre-launch. So the panel itself, the panel we are currently using has about 150 millisecond latency. That's something given to us, we cannot change. But if you are really powerful like Amazon, they just recently released new generation of Kindle, right? And that generation of Kindle, they were able to work with e-ink to change some materials, some chips in their design. So they were able to increase the driving voltage by a lot, and so making the screen itself going faster. But that wasn't really available to us. So we're working with 150 millisecond latency screen fixed, but we're trying to do it on the controller side to make it faster. One of the major thing we first try to eliminate is, you see, the e-ink screen, the e-ink panel itself wanted to be refreshed at a certain refresh rate. Usually that's 70 hertz or 80 hertz. And then you have your video interface, like from your PC or your computer to the screen, there is interface, HDMI, display port, whatever, is running under refresh rate. So the competitors, what they usually do is, because they think, oh, well, this e-ink is slow, let's don't bother with making a high bandwidth or anything. Let's just use an HDMI 1.2 or 1.3, and then or some 1.0, and then just run the interface at, say, 40 hertz. Then you create a mismatch between your interface frame rate and your screen refreshing rate. Then this mismatch means you need to introduce buffering on your controller. And that buffering naturally just creates some extra, 20 to 60 millisecond latency just because of buffering. And you also have, just because you run your interface at slower frequency, you run your interface, say, at 30 hertz, that's common, 40 hertz is also common. And your operating system, modern operating system, use GPU rendering. GPU rendering means you need to do double buffering, usually triple buffering. And then the more time you spend on a single frame, the much longer time, like 3x the time you're spending just waiting for the triple buffering to happen. And that also makes things slower on your PC side. So just by running our interface at a higher frame rate, matching the screen internal refresh rate, we can already gain a lot. That's not everything. Another thing that happens is competitors' controller usually do in kind of like a blocking way of doing things. So it would, like, the screen takes 150 milliseconds to display anything. So the controller would just send a new image to the screen and then wait the screen to respond. 150 milliseconds later, the controller now sends a new image in. So if you are extremely unlucky that the thing you want to display or the thing need to be displayed is right after internal refresh happened, then you have to wait another 150 milliseconds for the next refresh to happen. Then you're just waiting there doing nothing. But what our controller is doing is we're doing, and you can describe it as a continuously refreshing, or it's a pipeline operation. So there is no waiting our controller. Whenever the input is changed, the output is changed. Like the screen is being driven to that state, even though the screen will still take a while to get there. But we make sure like 150 millisecond, that's the hard limit, that's the lower limit of the screen, and we make that the actual latency rather than adding a bunch of other processing related stuff in front of that.
Yeah, very cool. I got an interesting, someone says that a very impressive demo. I see that. Let's just spotlight this demo a second, because I think Alex is, do you want to show some typing? Or do you want to show some stuff?
Yeah, I was just actually gonna do a few things. Give me a second.
I can come back to you in a moment if you want.
Sure. Just trying to see. Let's see. Switching a mode. Let's see. Is this the one? I believe so. Yeah. So this is a. Hopefully you can see this. Okay, I'm gonna make it a little bit larger, and hopefully you can hear me.
A little bit. I can hear you. Yeah.
Great. So yeah. So there's a specific typing mode that is made. We're able to type. Hello.
The CFP is currently open. Yeah. Thank you. Oh, that's funny. Thank you. Thank you for the plug-in. Yeah. Oh yeah, thank you, AMD. That's cute. I should say that AMD are actually the sponsors of today's stream, but also they are they run a program called the FPGA Playground. Words coming out of my mouth is having a hard time this morning. The FPGA Playground, they do. It's a program that we run at Crowd Supply. I'll show you it later, but yeah, very cool. This is super cool. That's a great typing demo, and I did spotlight you earlier when you showed the video demo. It looks great.
I can switch to the video.
Yeah, sure. Like
switch mode. Oh, that was a refresh. That's 16 level grayscale.
There we go. So yeah, you can get some pretty great scenes there. Very cool. All right, let's remove that spotlight. Oh no, wait, hang on. Let's add me back to stage. There we go. Add them all back to stage. I didn't want to spotlight myself. Ugh, terrible. I've got an interesting piece of feedback here from the audience saying I actually prefer having the frame 3D printed. Since this is a first launch, it'll help bring down cost and reduce the price of the product. And if the displays become unavailable, you can 3D print a new one. Interesting comment from Rainer there. Are you expecting that you'll have two versions available, like with case or print your own case? Some people do that. We see a range of casing options at Crowd Supply. We'll see the bigger ones sometimes do injection molding, but obviously that's really expensive. And if you're doing, you can't do that. If you're doing a $10,000 to $20,000 campaign, it's simply not possible. So we see a lot of 3D printed stuff. Increasingly, we'll see print farm stuff that's gotten a lot better. And we'll also see a lot of CNC milling as well for like the higher end but lower volume stuff. It's pretty pricey, but it looks really nice, so we're seeing those. I'd be curious to know like what options you've been exploring for your casing. I guess that's part of the reason why you're going to Shenzhen, huh?
Yeah. So one thing is CNC is still on the table, even though it will be really expensive for the aluminum. Maybe that's an option. And 3D printing absolutely works. The current one is 3D printed. Where the 3D printing doesn't work is we want to have an integrated kickstand for the monitor. And the 3D printing is just not strong enough for that kickstand. That's why we're moving to injection molding. But given that we are still planning to offer, say, a dev kit version, which doesn't come with a case, we do plan to provide a 3D printable case because
nice.
We already have it, so feel free to buy the version without the case and then just 3D print yourself.
There we go. Job's done. Brilliant. Got another question here saying, are the 13-inch panels matte or glossy? Important question here.
This one is matte. I think the color one does come in glossy, but I need to double check that.
One of the fun things that I liked about the typing was seeing dark mode. That one made me very happy when I saw it. Having dark mode on your typing screen was pretty awesome. I've got another question for Wenting. Is the hotbar manufacturing causing the breaking point in the long run due to higher power oscillation? Is it possible to drive them at a lower voltage? It's a very specific question. You want to comment on that?
I have to say, like, I'm not an expert on the screen itself. And then, so if it's about the screen itself manufacturing, unfortunately, I cannot answer that. E-Ink wouldn't tell me either. It's their trade secret. It's possible to drive them at a lower voltage, but then you are really using it out of spec. The spec really say you have to drive with this specific voltage. It's possible to run at a lower, it still works. But then it will also be slower, which is kind of defeating the purpose of our product.
Interesting. I would like to very briefly pick up on a point there that a lot of people who are new to e-ink, e-paper don't necessarily realize that e-ink is not the generic name for the technology. Would you be able to just briefly explain the difference between e-ink and e-paper?
Yeah, so e-paper could refer to any display technology that would resemble the paper. If you go extreme enough, you can even argue LCD as an e-paper, right? But then it doesn't make any sense. So usually people would say if it's reflective, then it's e-paper. If it's bistable, that can also count as e-paper. That's generally the thing, but it doesn't really need to look like a paper. That's the e-paper. And then e-ink is a company who is making e-papers using a very specific technology. They're electrophoretic screens. And then that's the screen that looks real like paper. And e-ink is the one who pretty much invented it and then brought it to mass production. The e-ink is also licensing out this technology to other companies. So there are a few more companies like DKE, I believe, or Waveform Tech is making also e-ink screens because they are basically buying material from e-ink and then just putting them together. So you can also call them e-ink screens. They're using e-ink license technology. There are also completely competing technology that's developed from ground up that's similar to e-ink, but actually not e-ink. For example, in the past, there is Cypix, even though they eventually got bought by e-ink, but they were not e-ink.
Okay, thank you for explaining that because I think not everybody knows that. I've got to saying hello here from Paul Stoffrigen, who's behind the Teensy project. So hi there, Paul, a local creator as well. We'll definitely be at Teardown. And we got oh hey, Trevor Flowers. Oh hey, thank you for joining us. And then I've got a fun question. I like this one. Does an e-ink screen defeat the purpose of dark mode? Good point.
I don't necessarily think so. So we've had someone else, Michael, who's actually been working on different prototypes of like what does it look like at the software level and at the interface level, and he's created some interesting demos of what it would look like to have a dark mode experience. I think there's a way where you can kind of combine both. But I don't think it defeats the purpose. But I think generally speaking, when you're looking at appearances, UI and UX, a lot of that there will be specific considerations that have to be made. And you kind of see this with existing like Android implementations or in implementations from other companies. So I think there's ways you can do it.
And I've got a couple of questions in the chat about compatibility and interoperability with other things. So we've got Georgie who says, will the current controller board be able to handle IGZO panels? And where was the other one I saw? There was, here we are, someone from Influence saying, could I theoretically just strap the board to any Kindle display? So I wonder if you might be able to talk about, interoperability and the challenges with that, or
yeah, so the IGZO display, it really appeared after I made this board. So the one you are seeing here wouldn't support it, but the one that will finally be on the campaign will support it.
Oh.
And then the Kindle display, that thing is, there are really many Kindle displays. Technically, it should be able to support them, but then I also don't have like every generation Kindle just to try themselves out, and also create an adapter board for that. Because even though the protocol is compatible, voltage is compatible, it doesn't mean the pinout is compatible, right? The Kindle, they change connectors every few generations. So you do need to create an adapter board for your specific screen.
Well, we do have actually, so someone else, so Soldered, the folks who do a lot of adapter boards for the Kindles, and they're all open hardware, and quite a lot of them, they're called Inkplate, that's it, the name of their range. So if you are interested in repurposing a Kindle board that you already have, I would definitely check out the soldered.com people. The Inkplate range is pretty interesting, and open source hardware, of course. So you can just go and look at their designs. Okay, I know Wenting has to get a flight, and we have to leave we have to finish the live stream in about 10 minutes, and I'm very conscious of the fact we haven't even looked at your GitHub yet. So should we take a little look at that, or is there something else you'd like to do with your final 10 minutes?
I think we're good over it. Yeah,
that's fine.
I think we've covered a lot here. All right, let's add my screen back into the stage and go over here. What have we got here? All right, what have we got here? Oh, yes, here we are. This is the AMD FPGA Playground. Thank you very much to them for sponsoring both our stream and Modos. I forgot to show that earlier. Thank you. And here is the GitHub for Modos. What have we got here? Glider, Caster. It'd be interesting to hear about those things. So you can go to Modos Labs up there. They also have a blog here, modos.tech. So there's a website, modos.tech, and I found that quite interesting. Before we go, just very quickly, I wanted to give a shout out to NLNet. So the Caster and Glider projects that we're going to be looking at and hearing about, they were both funded initially with NLNet. Is that correct to say that?
Yeah, so we received a grant from NLNet in order to sort of continue the work that's been done. If you go to NLNet, and should be Modos or Caster, forget exactly where to be. It was a bit of a naming convention of the URL, but you'll see it. Yeah, NLNet has been great to be able to receive that support. I actually saw them, Michelle at FOSDEM. It was great to be able to see the folks. And it talks a bit more about with the grant. Yeah, so really thank you for NLNet for the support, and also really encourage other makers and folks. NLNet does do like support different open source software, more aligned with like internet sovereignty, but they also do hardware.
They do.
Ourselves is one example. I know also Lucas with MNT Reform as well.
And Timon for Punera, and Bunny Huang. So there are many people in the open software ecosystem that have been successful in getting funding from NLNet. So if you are an open hardware creator, it really is worth knowing about NLNet. That's all I wanted to say about that. Let's go back to your GitHub. What is Glider? What is Caster? How are they related to what are all these names? Can you tell us a little bit more about this?
Yeah, so these are the Glider is this monitor. So at least the code name was Glider. That's what I call this monitor, and also the board itself. And then Caster is the actual firmware, or say the gateware running on the FPGA on that. The reason for the separation is I envision this gateware or the controller design to go into more products rather than just the monitor. It might go into our future stuff. So say if we end up doing the phone, as mentioned previously, Caster will play a role there, but that wouldn't necessarily be a monitor, right?
Yeah.
Also, just mentioned that the Glider you just realized, and is quite comprehensive.
Your documentation is wild. This is great. Look at your linked table of contents. Fantastic. Good for you. I like it. I've not actually looked at your docs before. You've got theory of operation on here. Wow, this is really great.
It's a good weekend read. As someone who's read it over the weekend, it's a good weekend read.
Wow. Okay, I will definitely put these in the show notes. I'm going to book this for myself. Actually, that looks great. I do like a good readable Do you know what I've been reading recently? This is going to make me sound really dull, but I've been reading the hardware design specifications for the RP2350, and it's the first time hardware specs have actually made me laugh. Like, it's so well written. Like, that's what I've been on. Anyway, yeah, that was an aside. This is great. Your docs are fantastic. Where do you want me to go and look? Have you got any? Look at your code, maybe, or do you want to see any? Do you want to show any of the hardware? Gosh, there's so much information here.
I think a quick scroll through the README will suffice to show folks.
Wow. Yeah.
Specifically in the code, but I think a quick show of the README itself. It's quite comprehensive. I think it covers if you're trying to learn about e-ink at the fundamental level and able to know more about the project itself. I think the READMEs do a phenomenal job. I think we're also, one of the things we want to work on as well is kind of organize it and also make sure it's accessible to like a broader audience as well.
Well, you've done a great job. I've actually not looked at these docs before, but I'm very impressed. Really cool. Great work. Let's see. So we've got apparently, Reiner's commented saying e-ink has a patent for the technology, but I believe that it recently ran out. That's interesting. And also we got another question here. Darsung released new e-ink monitors, 33 Hz to 40 Hz. What do you think? Are they using the same strategy that you are? Interesting. Are you familiar with that monitor?
Yes, I believe they are using the same strategy. At least from the result, looks really similar. So it wouldn't be wild to think they're just using the same technology. And also, they released it just recently, and I've been talking about all these stuff, open source it like at least for years. So it's totally possible they just come up with themselves, or they just decide to took my idea. Either way, that's fine.
I mean, yeah,
but,
it's kind of
but then they didn't take everything. Like there are several like tricks that I did, optimizations, further things to improve usability that doesn't seem to be in their product just yet.
Great.
And we're open.
Well, exactly. I mean, it's kind of the point, right? To make this stuff better.
Yeah.
You know. Yeah, I agree. It's really cool. I know that we've only got a couple of minutes left, so I wanted to do a quick shout out for how people can get in touch with you, how people can see. Obviously, we've looked at your GitHub, but I also noticed that you are shouting at your Discord server. Is that a pretty active Discord server, or are we better to find you on Blue Sky, or whatever? Where can people find you?
So if you want to get in contact with me directly, it'll be alex@modos.tech. Could also do a contact@modos.tech as well. We also do a Twitter, and as well we have a matrix. I think before the campaign gets launched, there's a lot of work to be done on creating a community forum, getting things on social media. So things that definitely need to be tidied up. But the Discord channel as well points to Wenting's Discord channel that talks about this, but also other different things kind of related.
It also talks about other my personal projects that may or may not be Modos, this monitor, like camera stuff or calculator
really
stuff.
Cool.
Yeah. So if you just want to get direct contact with me, then Discord is a good way. Or if you just shoot me a DM on Blue Sky, that also works.
What's your handle on Blue Sky?
I believe it's just Wenting.
Okay. Oh, you just got
Wenting
straight.
Blue Sky Social.
Okay. All right. I'll go follow you now. All right. Well, we've had a great chat with you. I know that you've got to go and catch a flight, but I also know that we're going to have another chance to talk about e-ink in depth in the new year, when I'll definitely have you on when your campaign goes live. Thank you so much, both of you, for joining us. Is there anything else you'd like to share or ask for? Are you looking for people to help you out on anything particular? Are you missing a component, or should everyone just go sign up to your campaign page?
I would say please sign up and sign up for the campaign page. Yeah, I think that would be one. Also, yeah, if folks want to get involved, I think, we've been working at this for many years. I think we're really focusing on trying to get this into production. We really want this to be something that is open, that can make it so it's available for most people, so that people can build on it. So this is us kind of put in this effort, but we're really trying to focus on creating a much wider community. So if there's any way you want to get involved, shoot us an email, alex@modos.tech. And yeah, I don't know. That's kind of what
my
I have to say.
alarm.
Yeah.
That's my alarm telling me finish the stream. Let Wenting get on his plane.
Thank you, Helen, so
Thank you.
much, and thank you everyone for
It's
the
really
comments
nice
and the
to,
questions.
yeah, and thank you everybody for joining us. Had lots of questions here today. And again, you've been fantastic guests. It's always really interesting to talk to you and find out what you've been up to. And I look forward to the next stage of your campaign. And congratulations again on quitting your job and moving to Shenzhen, Wenting. It's going to be great fun.
Thank you.
I hope you tell everybody about it on the internet. I'll just be watching what you eat with jealousy. All right, we've got some people saying hi. Thanks, that was super fascinating. Thanks, keep up the good work. It was all like everybody's very excited about what you're doing. So, without further ado, I'm going to let you go, get your flight, and see you again soon. Bye, everybody.
Bye.
Bye.